Hello guys, and welcome to this second episode of our CMake journey. In this video, we're going to set up our very first CMake project using C++, and we are going to compile and run it both on Windows and Linux. But before we get started, let's talk about the tools that I am going to be using in this series, because I don't think I really showed you that well in the last lecture. I have to say, by design, I really wanted this video to be short, maybe 20 minutes or something close to that, but it turned out to be lengthy because I had a lot of information I wanted you guys to know about. So I tried to split it into little chapters. If you look in the description below, you're going to see the timestamps and you can jump to a topic that is of interest to you. The editor I am going to be using is Visual Studio Code. You can use any editor you want, but Visual Studio Code is really cool in that it has syntax highlighting both for C++ and CMake, so it's going to make things a little bit easier. Here I have a window open to Windows PowerShell. So for example, I can go in here and open the Visual Studio Code editor. I'm going to show you how it looks. Okay, so this is Visual Studio Code. This is how it's going to look. If you go down on this tab that says extensions, you're going to click on it and you're going to have the ability to install the extensions we need both for C++ and CMake. I do recommend installing this extension for C++. It's going to give you the ability to do C++ stuff inside Visual Studio Code. Another one I recommend for this series is CMake Tools, because it's going to give you syntax highlighting for your CMake commands, and it's going to be really easy to see things. I think if you hover over CMake commands, you're going to also be able to see the documentation, which is really cool. It's going to improve your productivity in your journey as a C++ developer using CMake. So this is the first thing we're going to use. If you want to get access to that, you can go to your favorite search engine and say Visual Studio Code. Okay, we're going to get our link here. You're going to click on it. And you're going to see all the information about Visual Studio Code. They detected that I am on a Windows machine, so they gave me the link to download for Windows here. But I think if you scroll down, you're going to have different links for different operating systems. You can use this on Windows, Mac, and Linux, and this is really cool. The second thing you're going to need is a C++ compiler. And I happen to have different compilers on my system here. For example, I have the compiler that comes with Visual Studio, and that's not Visual Studio Code, that's Microsoft Visual Studio, the monster IDE from Microsoft, and it is really cool. If you install it, you're going to get access to the compiler that comes with this IDE, and you're going to use it on Windows, and it's going to work really well. Please note that I am using a recent version of Visual Studio, and if we go here and say developer, we're going to get a PowerShell for Visual Studio. If we open this, we're going to see version information here. So this is Visual Studio 16.10. This is a pre-release version. It's not the released version. I think the current release is 16.9, but if you get 16.9, it's going to work pretty well for what we're going to do here. So make sure you have this compiler available. One thing you need to know about this compiler is that to have access to it without doing too much work, you're going to go through the developer prompt. So let's do that. We're going to go to Start and say Developer. You're going to see that we have a prompt and a PowerShell for the current version of Visual Studio that you have installed. The reason we have to do this is that if you use a regular command prompt, for example, let's do CMD here. And this is going to give us a regular prompt. With this prompt, we want to be able to directly use the C++ compiler from Microsoft. For example, let's try and call the compiler. If we do this, it's going to say the compiler is not recognized because we don't have an environment variable set for this little guy here. So be careful about this. It is possible to set this environment yourself and do all kinds of crazy things, but we're not going to go down that path. We're going to use a prompt that comes with Microsoft Visual Studio, and it's going to have everything set up, and we can call our compiler directly, and it's going to work. So make sure you have this. Another compiler you can use is GCC on Windows, and I showed you how you can get access to that in the last lecture. If you didn't watch that, please go back and make sure you have a GCC compiler installed on your Windows machine. If I go in here, for example, and say G++, and I say version you're going to see that I have access to this little guy. I can use it, and we're going to use it in this course. So make sure you have an editor that you're going to be using in this series, and you have a C++ compiler at least on Windows. You can use Microsoft Visual Studio, that's going to work. You can also use GCC. Another thing I really want to point out, because some of you are going to run into this problem, is the setup of environment variables. Let's type env on our start menu here, and we're going to have this window saying edit system environment variables. We're going to click on this. We're going to go into environment variables, and you can set up environment variables either for your own account or on the entire system. So if we go down here in system variables, we're going to see that we have a path variable, and whatever you need to access directly on the prompt will need to be set as an environment variable here. So for example, you see I have in a path for my GCC compiler, which is living in my C drive. I have a path to another thing we're going to be using later called Ninja, but don't worry about this. The point here is that if you want to directly call a program on Windows on a terminal, you're going to set up an environment variable for that. And you see we are able to call G++ because its environment variable is right here. Okay, the last thing you need for this series of tutorials is CMake itself. And you can go to the website for CMake and download it. Let's go there and show you that. And the website is here. If you hit download, we're going to get to a page where we can download a recent version of CMake. You see we have many versions here, and we don't want this 3.20 because it's a pre-release. We want stable releases. You see the latest release is 3.19.7. You can get that if you want. For example, on Windows, you can download these binaries. They are going to work and install them. On Linux, you might download these things you see here. They are going to work. On a Mac, you can get this and you are going to have access to CMake. One thing you have to be sure of is that these guys are also set in your environment variables. For example, if I go in my user environment variables, you're going to see that I have a path to where CMake is installed. I have CMake bin. If we go there, let's actually go there and really show you. So if I go in C and choose CMake and do bin, you're going to see that I have my CMake binaries here, and I am able to use them from any terminal on my system here. For example, here I can type CMake version, and it's going to tell me the CMake version I have here. Another tool we're going to need is Git, which we are going to use to do version control on our C++ project with CMake. The main thing we're going to use this for is to be able to transfer our project from Windows to Linux. We're going to set up a Git repository, and we're going to push to that from Windows, and then we're going to download the code on Linux and be able to do things with that. If we happen to do changes on the Linux side, we also have the option to push back to GitHub, and then we can sync those changes from Windows. You're going to see how cool this is. I have to say, I am just going to use Git. I am not going to teach you how to use Git. If you are rusty on Git, I would recommend reading something about it or checking a few videos on YouTube, and you're going to be really up to speed very fast. So in the reminder of this video, I am going to assume you have Git installed either on your Windows or Linux machine. Okay, so on Linux, you also need to have the same set of tools. For example, here I have a terminal window open on my Linux system here, and you're going to see that I have CMake installed. And if you want to know how to install this, you can come to the download page here and download the binary for Linux. What I did was download this little guy here. I realized I had told you that we could use an older version of this on Linux, but I changed my mind and I really wanted to use a recent version of CMake because we want things to be consistent on Windows and Linux. Okay, so this is the version we're going to use in this tutorial here. So what you would do if you wanted to install this, you would grab this link here, for example, and you would come on your Linux box here and say wget and put the link. Did we grab the link? I don't think we did. So we're going to copy link location, and we're going to put that here. If we do that in download, we're going to download this little guy. It's going to download this. It's going to take its time. Then when it's downloaded, you're going to extract this little guy. Let's wait for it to download so that you can really see everything. Okay, once your download is done, you're going to have this little guy stored on your computer. Here I am in my home directory. Let's do pwd to really make sure, yes, we are here. And you're going to see that I have this little thing here. Once you get it, it's not going to be executable by default. If I do lsalh here, you're going to see that this guy is not executable. You can see that right here. If you want to make it executable, all you have to do is chmod and say +x. This is one way to do it. There are many ways, but we're going to use this way. And we're going to say CMake here. And we're going to say that this is the file we want to mark as executable on this system here. And once I do lsalh again, you're going to see that this guy is now executable and it has turned green. If you run it, it's going to self-extract in this directory here. And we are basically going to have this guy, this folder here, and we can go in and have access to CMake here. So for example, if I cd and CMake, and I am going to do ls, you're going to see that we have a bin directory. If we change into this bin directory, you're going to see that we have the same things we had on Windows. Okay, so CMake, CMake GUI, cpack, ctest. These are things we're going to be using in this series, but for now we're going to be happy using CMake here. And let's go back and show you that it is actually the same things. Okay, so you can see that here. We have the exact same of tools here on Windows and Linux. Okay, once you have this little guy, it's not going to be set up to be usable from any place on your Linux machine. And if you need to do that, you need to add the path to your CMake binaries to the path variable on your Linux system. If you don't know how to do it, here is a simple tutorial on how you can do that. Basically, what you need to do is to open the bash rc file in your user account. So what I am going to do here is say nano. So I want you to see all these things because I want us to be on the same page here. So we're going to say nano, and we're going to say bash rc. And if we open this, we're going to have this file here. And all you have to do to add this to your path is add the command to the last line here. You see, we have export path, and the path we put in is exactly the path to our CMake directory. If you do this, this is going to be available anywhere. And you will be able to run CMake and do version, if I can type CMake. And you're going to have your CMake version here. Another thing you need is a C++ compiler. In the last lecture, we installed G++ on Linux, and you know already how to do this. If we do G++ and do version, we're going to have this compiler here. So this covers the tools we want to use. I also have to point out that if I need an editor on Linux here, because this is a headless Linux system, we don't have a GUI on top here. But if I need an editor, I can use the Visual Studio Code editor I have on my Windows machine. And this is really cool. So let's do ls here and cd, for example, in my C++ project here. And if I run code, we don't have code installed on this Linux box, but Microsoft is using some magic to communicate to the Visual Studio Code instance we have on Windows, and it's going to use that. So if we wait a minute, we're going to see that this is going to open up my project that is living on my Linux system, but we're going to be using an editor living on the Windows side, and this is really cool. So if you go here, you're going to see that this is Visual Studio Code for Windows, but we are able to manipulate things on our Linux box. For example, if you look on the terminal here and we type uname, we're going to get the information on our Linux box, and the code we are manipulating here is really living on Linux. If we do ls here, you're going to find the programs that we have on our Linux box. So I don't want you to be confused if you see me use Visual Studio Code manipulating things I have on my Linux box. And this covers the tools we're going to be using in this series. Okay, so now that we have our tools set up, we're going to start and use CMake to develop C++ projects that are cross-platform. And the design we're going to follow, we're going to set up a Git repository somewhere. So let's do that. We're going to say repository. And this repository is going to be manipulated by things we have both on Windows and Linux. Okay, so we're going to set up our Git repository, and we're going to grab the files in that repository and use them on Windows. So we're going to pull the files, and then we're going to do our stuff on Windows. We're going to set up a C++ project. We're going to do some CMake commands, and we're going to build and compile this project and run it on Windows. Once we are happy, we're going to push things back in our Git repository. Then we're going to pull these things in Linux, and we're going to do our stuff, compile and run this on Linux. And if we happen to do any change on the Linux side, we're going to be able to push them back so that we can really sync what we are doing on Windows and Linux here. So this is the flow we're going to be following. So let's get started. We're going to hop over to GitHub. Let's do that. And I am going to create a new repository. Let's click on the plus icon here. We're going to say new repository, and we're going to call this CMake series. I think this is going to work. And we're going to put in a simple description. And we're going to say that this is a YouTube series. And I want to make this public. I am going to add a README file, and I am going to add a gitignore file. And the template I want to use is the CMake template. We can do that. And I am going to choose this little guy. And after I do this, I can create this repository here. So let's create it. Okay, we have the repository created here. Now what we want is to pull this and make it a starting point for our projects that we want to do here. So let's grab this. I am going to grab the link here, and I am going to hop over to my Windows terminal. I can do this, and let's go somewhere. Where do we want to go? I want to use a folder on my Windows machine here. Let's choose this. Let's go to E, and I want to go into Sandbox. This is where I want to put this little guy here. So let's change to that location. We're going to do E, and we're going to CD to that location. I think the text is really bad here. So I am going to use my Windows terminal thing here. Let's grab a PowerShell, and we're going to do E, and we're going to CD to that location. And then I am going to do git clone. You also need to make sure that you have Git installed on your system. We're not going to clone our own folder. So let's grab the Git repository link here. If I click on this little guy, this is going to copy this. Let's go in here and clone our repository. Okay, so now we have access to this folder on our system. The folder is going to be called CMake series. We can cd into that. Okay, if we do ls, you're going to see that we have our gitignore file and we have our readme file. Let's go there and see what we have in there. So we're going to go in a CMake series because that's our folder. We want to look at the gitignore file. Let's open it up with some editor. I am going to use Notepad++ here, and I want to ignore build files that I get from CMake. What I am going to do is say star symbol, and I am going to ignore anything that has the name build inside. We are also using VS Code, and VS Code is going to have some configuration files that really belong to me on my local system. I don't want to push these things to GitHub, so I am going to ignore anything that has .VS Code in that. I realize there might be better ways to do this, but this is going to do because we really want to move on with whatever we are doing here. So I am going to save this, and what I am going to do is create a folder in here that is going to be our first project. I am going to do app002 to mean that this is the second episode of our tutorial, and I am going to go inside. And the first thing I want to do is put in a file which is going to be our starting point here. It is a main CPP file which contains the program that we're going to be building. And we want to open this little guy in Visual Studio Code. So the way we can do that from Windows is, let's go there and make sure we start this from a terminal that has access to the tools from the compiler from Microsoft. So let's grab the path to our thing here. This can be confusing. I am really sorry if it is. If you have any problem, please make sure to ask. I will do the best I can to help you out. But we have to do this. So we're going to cd to this location here, and we're going to do ls to see what we have in there. We have our main CPP file, and we want to start Visual Studio Code from this location here. This is going to open Visual Studio Code from here. And we had another instance of this little guy. Let's close this. We don't need this anymore. And we have our project open up here. We can look at this main CPP file. And inside we have a C++20 project. It is C++20 because we are using concepts here. And you see we have squiggly lines here because Visual Studio Code doesn't know how to interpret the code we have here. It doesn't know that we really want C++20. So what I am going to do is let Visual Studio Code know what kind of C++ version we want this project to try and use. The way to do that, you hit Ctrl-Shift-P to bring up the command, and we're going to choose C++ Edit Configuration UI here. And we're going to have a set of settings here. Since we are on Windows, we can leave this the way it is. It picked up the C++ compiler from Microsoft, but we want to go down and tell it which C++ standard we want to use. So we're going to choose C++20 here, and we're going to close our thing. And notice that this is going to generate a folder called .vs code. This is a configuration folder that Visual Studio Code uses to try and make sense of the program that we have here. Okay, now our C++ project is ready. We're going to have to set up CMake and use it. To use CMake, you have to set up a CMake lists.txt file. And we're going to create that in our folder here. So we're going to click on this plus icon here and say CMake lists.txt. This is the name you have to put here. CMake expects this. And if you don't put this here, you're going to have problems. So make sure you are exactly naming that CMake lists in plural.txt. Once we have this, we can start and do some CMake magic here. And to do CMake, the first thing you have to specify is the minimal version of CMake that you want your project to support. The way you do that, you say CMake minimum required. You see we have autocomplete here because we have the CMake extension installed in Visual Studio Code, and that happens to be this CMake tools extension here. If you are using Visual Studio Code, this is something really cool to have. Okay, so we are going to specify the version of CMake we support. But one thing I want you to see is that you can hover over this command here and see the documentation for this. And this is where Visual Studio Code really shines. So we can see that this is going to require a minimum version of CMake. This is the syntax we have to use here. And if you go down, you're going to see all the information on this little guy. So sets the minimum required version for CMake for a project. And you can do all kinds of crazy things here. So we're going to put this in. We're going to say version. And we're going to require people to have 3.5 because I think this is a reasonable minimum requirement that is going to still allow you to use cool stuff from newer versions of CMake. Okay, so this is going to require people to have this minimum version of CMake to be able to work with our project. And another thing I should point out is that this is a CMake command. The statements we have here are called commands in CMake terminology. And they really look like functions in programming languages, even like in C++. Okay, so what we have inside the parentheses here are what looks like parameters. You are going to separate them with spaces. It is even possible to separate these things and put them on different lines. This is going to work, but we're going to keep this on one line here because that's easier. The second command we're going to use is the project command. And this is going to allow us to specify information about our CMake project here. If we hover over this, we're going to get the documentation. We're going to see the syntax we can use to do these things. For example, with the project command, you can specify the project name, you can specify the version, the description, the home page, the languages. We're not going to use them all, but we're going to specify the project name. Let's call this Hello App. And let's look and see if we have something else we can specify. For example, we can specify the version of our project. Let's go down and put that here. We're going to say the version, for example, is 0.01. You can use any version you want. What else can we specify here? Let's hover over here. We can specify the description for our project. Let's do that. And we're going to call this the leading Hello World app. Okay, so what else can we put here? Let's go down We can specify the languages. This is really important because we want this to work for C++. So we're going to say languages, and we're going to say CXX. This is the syntax CMake uses to mean that we want this project to be a C++ project. And once CMake sees this command here, it's going to have a lot of information about our project here. The most important one being the C++ language. The most important one being the language that we want this project to use. So this is really cool. Okay, so now that we have this, we need to specify what we want to build with CMake. And we do that using the add executable command. So we're going to say add executable. And we're going to specify the name of the application we expect to get from this. We can call this hello app binary, to really make sure that it is a binary, but you don't have to name it like this. After this, you're going to specify your source files. And in this case, we only have one source file. So we're going to put main.cpp. And this is going to be almost complete. But we want our project to support C++20 because you notice we are using a C++20 feature here. So we want to support C++20. In CMake, there is a special command you can use to pass flags to your C++ compiler. And that happens to be target compile features. This is what we're going to choose here. And again, if you want to learn more about any of these commands, you can hover over the command and you're going to see the information about this. So we're going to tell it that if it is compiling hello binary here, it's going to use C++20. This setting is going to be private to our project here. And please don't dwell on this private thing. It is a little bit advanced for now. We are just going to put this here because this is really our project. We don't expect anybody else to use this executable. That's why we make this private. But there is a little more to these private keyword here in CMake, and we will have a chance to explore this a little more in future videos. For now, we're going to put this here, and we're going to say that we want C++20. The way we do that, we say CXX, and we're going to say std, and we're going to say 20. And how do I know this? I went to the documentation for this little guy, and I saw what I can pass to this command here. Now we have a fairly complete CMake file that we can use to build our project. We're going to save it. We're not going to do any more here, and we can close this left pane here because we don't want to see all these red lines saying that there is something wrong with our project. This is Visual Studio Code having a problem understanding the project here, but it is going to work. Let's close the left sidebar here. And don't worry about this 2 you see here. This is get telling us that we have a few things we can add to our project. But for now, we're just going to use CMake and ignore everything else. Let's bring up a terminal we can use on our project here. And we are on Windows. So what we want to do is to build this project using CMake. We can clear and do pwd to see where we are. We are in CMake series. If we do ls, we're going to have app002, our project. We can cd into that. If we do ls, we're going to see our project here. We have a main cpp file, but we don't have a CMake lists file. What is going on here? Let's cd into VS Code and see if we happen to put that in there by error. Yes, that's where it is. So what I am going to do is go to my folder here and go in this folder, and I am going to grab this little guy and put that on top because I don't want that to live inside the VS Code folder. It should live on the same level as our main CPP file here. If we go back and do ls, we're going to go up a little bit and we're going to have our CMake lists.txt file here. Now we can use CMake. Make sure you have CMake in your system. We're going to do CMake version CMake version here. We're going to see our CMake version. Okay, before you use CMake, note that you can get some help from the tool itself by saying CMake help. This is going to give you a few things you should know about your CMake installation. Let's go up and see that. We're going to see the usage of CMake. You can read all this if you want, but I am going to cover as much as I can so that you can really understand these things. So know that you can get the help from CMake here. Okay, so what we're going to do is run CMake in this directory here and tell it that it should really use this CMake lists.txt file to do our thing. Let's run CMake here. And we're going to tell it that it should work in this directory and use this file here. And we save that by using a dot. If we do this, we're going to see that CMake has already selected our Visual Studio compiler. This is the default behavior of CMake. If you run it on a given system, it is going to select the default tool to build your project. And we are on Windows, so it's going to select Visual Studio to try and build our project here. And you're going to see it's going to try and select the compiler, and it's going to say configuration done and generation done. I want you to notice these two things because they are going to become important as we progress in the course. CMake is going to do its thing in two steps. There is configuration and generation, but we're not going to go deep into these two things here. What I want you to see is that it is saying build files have been written to this location here, and it happens to be our project here. If we do ls, we're going to see that now we have a lot of things in here, and this is really bad because it's really hard to keep track of what we really want in this project. For example, we have our main CPP file, we have our CMake lists file here. This is really what we are interested in, but CMake has put all this junk in the same folder that we have here, and we don't want this. Okay, now CMake has generated the build files we can use to build our project on Windows, and it has generated a solution that we can build with Visual Studio. Let's open Microsoft Visual Studio and show you that we can actually use that to build this project. I can open my version here. Okay, Visual Studio is up here. I can say I want to open a project or a solution. This is going to give me the option to go and find my solution file. I think we are going to go in E sandbox. We're going to choose CMake series. We're going to choose EP002. And you're going to see that we have hello app.sln. This is the solution file that was generated by CMake, and this is really cool. We didn't have to specify our compiler flags or whatever. CMake is going to generate our project, and we can build it with a native tool on our operating system. This is where CMake shines. Okay, our project is open here, and if you go down, you're going to see that we have a few things here. For example, we can see our source files. We have our main CPP file in Microsoft Visual Studio. This is really cool. We can see it here. But the most important thing we can do is build this little guy. We can come to build here and say build solution. We can do that. And if we bring this up a little bit, we're going to see the progress of our things. We're going to see that it is building, and we're going to see that the build was successful right from Microsoft Visual Studio. And this is really cool. Now this has generated our binary, and the binary is living somewhere in our folder structure. If we go back to our project here, we're going to see that we have a few more things generated in this folder here. And we're going to see that we have a folder called debug. If we go in, we're going to have hello app binary here. And if we open it, we're going to see that it can run. Let's bring up our terminal here. And we're going to do ls again to see that we see the same thing. You see we have a debug folder. So we can say debug and say hello. And if we do this, you're going to see that the program is going to run, and it is what we expect to see if we run this C++ program here. It is going to say hello C++20 with CMake on Linux and Windows, and it is going to print the sum here. And it is the exact same thing we see when we run our program here. This is really cool. But we really have a problem. This is cramping all the build files in the same folder where we have our source files, and now it is really difficult to keep track of what is our source code and what is not. For example, the main CPP file is here. We have our CMake lists file, and it's really not easy to keep track of all these things. And what we just did here is called in source build in CMake terminology. And what this means is that your build files are going to be generated in the same location where you have your source code. And this is really bad. I don't recommend it. What we could do is set up a separate folder and use that to contain the output of CMake, and that's going to be really good. So what I am going to do now is remove all the crap that was generated by CMake, and let's select all those. I think I should close this in Visual Studio because it won't let me delete this if it is already open. So let's close this. It has done its job, and we are going to delete these little guys here. I think I can remove them. And now our project is clean again. What we want to do is set up a folder which is going to contain our build files. Let's do that. We're going to set up a folder called build, and that's what we're going to use to build our project. So what we're going to do is cd into that folder. We're going to do ls. We're going to see that we have a build folder here. We're going to cd into the build folder, and we're going to tell CMake to build our project, put the files in the current directory, but it's going to be using the CMake list.txt file that lives in a folder above us. And the way we're going to say that, we're going to say CMake, and we're going to pass 2 dots to tell CMake to go up and find the CMake list.txt file here. If we run this, CMake is going to do its thing. It's going to select the Visual Studio compiler. It's going to generate the build files, and the build files are going to be located in a separate build folder. If we go up again, we're going to see that our source files are now a little bit clean because we have the source files and we have a build folder, and we can hop into the build folder to build our project. So for example, we can open this folder in Microsoft Visual Studio like we did before, and it is going to build our project. But one thing I want you to know is that you don't even have to open Microsoft Visual Studio because it's really slow and it's going to slow things down. What I would encourage instead, if you don't want to go through the clutter in Microsoft Visual Studio, please know that I don't hate Microsoft Visual Studio, but sometimes it is slow. So if you happen to be a fan, don't go bad on me here. Okay, so what we're going to do instead is call the build tool that Microsoft Visual Studio uses to build projects, and we have access to that, and this is really cool. But to have access to that, we have to use a Windows specific terminal. So we're going to come back in our developer PowerShell here, and we're going to do ls. We're going to cd into the build directory, and what we're going to call is a tool called MS-Build. I want you to know this, and what you can do is pass it the solution file that you want to build, and it's going to use hello app.sln here. If we hit enter, this is going to use the Microsoft magic to build our project, and you're going to see that it's done building our project. And if we do ls in here, we're going to see that we have a debug folder, the exact same thing we had from Microsoft Visual Studio, and we can run our program. We can say hello app. No, we don't need to say hello app. We can say debug because that's where our binary is generated, and we can say hello app binary. This is going to run our program here, and this is really better. Now the build files are not generated in our source folder. We're going to have the build files generated in a separate directory, and this is going to be really cool. For example, if we don't want these build files again, all we have to do is remove this folder, and we can start over again and build our project. This is really cool. So this is one approach many projects use to do out of source build. And this is called out of source build because the build files are going to be completely separated from our source file here. But some people go even further and do things in really crazy ways. So for example, I can close Visual Studio Code here because I am going to change things a little bit. So I am going to put in another folder. I'm going to call that source. And I am going to put my source files in this source directory. I am going to grab everything and put those in our source directory. Now this is going to be the folder containing everything we need to set up our source code, but the builds are going to be generated in a completely separate folder. So we can take out everything here. I think we don't need all this crap here, so we can delete that. And we're going to hop over in our source directory. We're going to open this in Visual Studio Code. I think we can do that. Let's go back. And what can we do? going to cd, and we're going to cd into build because that's where we want to build our project. Now we're going to call CMake, but we're going to tell it to go into our source folder and find the CMake lists.txt file. If we do this, you're going to see that it's going to do the same thing it's been doing. It's going to use the compiler from Microsoft. It's going to generate our build files. If we do ls, we're going to find them here. But if you go up, you're going to see that now things are completely separate. We have a build folder, we have a source folder, and our builds are going to be generated in the build directory here. And this is really cool. Okay, so this is what is recommended. If you want to use CMake, you have to separate your source files, and I happen to prefer doing things this way because my source code is going to be completely separated from my builds. And this is really how you use CMake. And we are happy our program is building and running on Windows. Now we can push these things to GitHub and see if we can build this project on Linux. So I am going to go up and go up again because that's where I have the root of my Git project here, and I am going to do git status, and I am going to see that I have modified my git ignore file. I have added a folder for our second episode here. I am happy with the changes here, so I am going to git add them, and they are going to be added. I am going to say git commit, and I am going to say episode. You can put in whatever you want. I am going to commit my changes here. Okay, so if you look here, we have the files that we don't really want here. What is this thing? We have a hidden folder .vs that was generated by Visual Studio when we opened our solution with Microsoft Visual Studio, and it has left this thing, and so we're going to remove this because we don't want to push this to GitHub. Okay, so what we're going to do is make sure that we are showing hidden files and folders on our Windows system here. And one way we can do that on Windows is come to View, and we're going to go to Options to the right here. If we click, we're going to see a window pop up. We're going to click on that, and if we go to the View tab and go down, we're going to see an option to show hidden files and folders. So make sure you have this setting in, hit apply, hit OK. And if we go in our project now, you're going to see that we have a Git folder. We want to keep this, but if we go inside our second episode here, you're going to see that we have a .vs folder that we don't want. So I am going to remove this. I'm going to right click and say delete. This is going to go away. If I come back to my terminal and say git status, let's do ls, and we're going to do a git status. We're going to see that we removed these things we don't want. I am going to add my change here and do a commit. And now we have everything we want here, and we can push this to GitHub. We're going to do a git push. This is going to push our things to GitHub. Okay, our push is done. Everything is now on GitHub. If we go back to GitHub and refresh on our repository here, we're going to see that we have an episode 2 here. If we go in, we're going to find our CMake list.txt file. This is really good. And we have our main CPP file. And this is going to contain our C++ code here. Nothing complicated. So what we want to do is to hop over to Linux and grab a copy of this code here and build it on Linux. And that's going to be really cool. So what we're going to do is bring up our Linux box here. We're going to cd into my home directory. If I do pwd, you're going to see that's where I am. I am going to do ls, and I am going to git clone my project. And let's wait for this to come down. Okay, the clone is done. If I do ls, I am going to find that I have a folder named CMake series. I am going to cd into that. And if I do ls, I'm going to find my second episode. Let's cd into there. And I can create a build directory because we want to do out of source build. So we're going to do mkdir and say build because that's what we want. We're going to cd into our build directory. Then we're going to call CMake. We're going to say CMake, and we're going to tell it to find the CMake file in our source folder. If we run CMake, we're going to see that it's going to do its thing. It is basically the same thing we did on Windows, but you see that it's going to choose the GCC compiler, our version, which happens to be 10.20. If we do G++ version, we're going to confirm that. And the build files have been generated on Linux, and the default build system is Makefiles on Linux. So to build our project here, if we do ls, we're going to find our Makefiles. All we have to do to generate our binary is say make. If we do this, this is going to go through the process to generate our binary, and you see it has built a target called hello binary. And if we run this, we're going to see the same message we saw on Windows, and this confirms that we are able to use CMake and C++ to set up cross-platform projects that we can build both on Windows and Linux. And this is the flow you usually have to go through. You are going to have a version control system like Get Somewhere, and you're going to be using a remote service like GitHub or GitLab. You're going to do things on one platform, you're going to push to GitHub, and then you're going to pull from another platform, and you're going to build use CMake, and this is going to be really cool. So for example, if we go up and change into our source directory, we can open the main CPP file. Let's use Nano because I don't want to go through, or we can even use Visual Studio Code. I want you to see this. We can run code from here, and this is going to open Visual Studio Code that we have on Windows, but it's going to be manipulating files in Linux here. So I can go in my main CPP file. This is what I want, and I'm going to change to add 7 and 3 here. Let's do that. Okay, so we're going to change this. We're going to save, and then we can close Visual Studio Code here because we don't need that anymore. We're going to change into our build directory, and we're going to run make. This is going to build the program again, and if we run hello app, we're going to see that the sum is 10 and it was 12 in a minute. So this is a change we did on Linux. Once we do this, we need to commit this and push this back to GitHub, and people from Windows can pull these changes in and use them. Let's do that and really show you that we can do this. So we're going to git add our changes. Okay, we're going to do git commit. Now we need to do this from the root directory. Let's do that. So we're going to do git status here. CMake series. We're going to add our changes. We're going to do git add. We're going to commit. And now our branch is ahead of what we have on GitHub. We need to push these things to GitHub. So we're going to do git push. This is going to push things to GitHub. And I need to specify my username. Why? Let's say that. I am going to put in my password here, and I am going to push. Okay, if we go back to GitHub, we're going to see these changes in. Let's refresh a little bit. And you see that the last commit was saying apply changes from Linux. Now what we need to do from Windows, if we need to build this, is to come to our PowerShell window here. We can do that. Okay, so once on Windows, we're going to do a git fetch. And we're going to do a merge. This is going to merge in the changes we had from Linux. And if we go to our episode 2 folder, we're going to cd into there. And we're going to cd into our source directory. And if we cat and see our main CPP file, we're going to see now that we are adding up 7 and 3, and we can build this project again. So what we can do is cd into the build directory, and we're going to run CMake, and we're going to tell it to find our CMake lists.txt file in our source directory. This is going to do. Let's build. You're going to see that the build files have been generated, and we can run ms build hello app solution. This is going to build our program again, and if we run the program in debug hello, you're going to see that now the sum is 10, and we are able to pull the changes that we had from Linux. Okay, so now that we have this working, there is one thing I want you to really keep in your mind. Let's make sure this thing is opened in Visual Studio Code. We're going to open up our source folder. We're going to bring this in here. And one thing I want you to be careful about is to make sure that the CMake minimum command is there. And I am going to take this chance and show you how we can do comments in CMake. You do comments by using the number sign symbol here, and this is going to comment out the line. Once we do this, and we try to run CMake, you're going to see that we're going to get a problem. We're going to get an error. CMake is going to not run, it's going to throw an error, and we're not going to be able to build our project. So let's bring up a terminal here. We can do that right from Visual Studio Code here. We're going to do ls, we're going to see our files here, but if we try and cd up and go in the build directory and run CMake here, you're going to see that we're going to get an error. And this is really not clear or good. Let's use our terminal window here. I think this is going to show things better. So let's clear, where are we? We're going to cd into our episode 2 directory. We're going to cd into build. And we're going to run CMake and tell it to go in our source directory. If we do this, we're going to get an error. It's not really a compiler error, but it is an error thrown by CMake. And it is going to say, CMake minimum required, this is not there, and this is a command that should be there for CMake to be able to do its job. So you have to make sure this thing is really there. And I know some of you are saying, what if I take this and make it show up later in my project? For example, I put it after everything here. This is not going to work because CMake really needs to see this earlier when it is processing the CMake lists.txt file here. If we build this, if we try and call CMake on this, we're going to get the same error. Let's do that. And we're going to get an error. And this error is really coming from the fact that we don't have the CMake minimum required command where it should be. If we put this on top again, this is going to work as expected. And if we go down and run this command, I think we can do that from here. You're going to see now the build files are going to be generated and written to a folder here where we can really do things. So make sure you remember this. And this brings us to the end of what we really wanted to cover in this video here. The basic idea was that we could use CMake to set up C++ projects. We could build both on Windows and Linux. We had a chance to look at the CMake syntax we use to set up a minimal project. This is really a hello world version of CMake, if you ask me. And we had a chance to learn about these few commands. You have to keep them in mind because you're going to see them a lot in your CMake journey. Okay, so we saw that our CMake list.txt file is to be read by CMake, and then CMake is going to detect the operating system we are trying to build our application on, and it's going to generate a native project we can build directly. We have seen that on Windows, the default was to generate a Visual Studio project. On Linux, we generated a Unix Makefiles project, and we're going to see how we can tweak these things in a few videos ahead. But for now, note that the CMake list.txt file is going to be where we spend most of our time when doing things with CMake. Another thing I want you to keep in mind is that we didn't really have to pass all these crazy compiler flags to let our application be compiled. If you remember in the last lecture on Windows, we had to do something like this with the compiler from Microsoft. We had to do something like this with GCC, both on Windows and Linux. And you see that these commands are different. In this video, we saw that once we had our CMake list.txt file, CMake is going to take care of generating a project we can build on our system. And the project is going to be ready to use using the settings we have in here, and CMake is going to transfer these settings in the projects that we generate here. So the project we generated for Visual Studio would already support C++20, for example, and the project we generate on Linux would also support C++20 by default, and this is really cool. Okay, so this is really all I had to share in this video. I hope you found it interesting. Again, I apologize. It turned out to be really lengthy, but I wanted you to see these things. And we're going to be reusing all this knowledge in future videos. So this is a really good foundation if you are new to these things that we are doing here. If you have any thoughts or suggestions, please do share it in the comments below. I really want to hear how you find these videos. If you think they suck, please do tell me. If you find them useful, please do tell me. I really want to know. Okay, so this is really all for today. I will see you next time.